Hi friends, today we will discuss Newton's laws of motion and this physics subject for Vital Foundation section for 8th class and also for 7th class students also. So today we will discuss and know about Newton's laws of motion. In Newton's laws of motion we will learn. Let's start the Newton's laws of motion. So let's learn about the Newton's laws of motion. Let's start this video. So here Newton's laws of motion, here are some definitions, and the force is the main thing in Newton's laws of motion. So if force is the main thing, so we have to know about what is force. Here is the definition. Okay, see, here is the force, and in the down its definition. Okay, let's see. Okay, definition. Okay, a force is an external agent which changes or tends to change the state of rest or uniform motion of a body or changes its direction or shape. In very simple terms, force is defined as pull or push. It is denoted by the letter F. Okay, this is the definition of force. In easier way, in the very simple way, force is defined as pull or push. So I will say a simple definition for force. A force is a pull or push of an object. This is the definition. Wait a minute, I will write. So a force is a pull or push of an object. So I have written object short form. A force is a pull or push of an object is known as force. Pull or push of an object is known as force. A force is a pull or push of an object. So we have, and the force is denoted with the capital letter F. Capital letter F. Force is denoted with capital letter F. Okay. And we have learnt about the definition of force, and we will know about effects of forces. So here is the effects of forces. See, effects of forces. In effects of forces we have 5 points. Let's see those 5 points. So these are the points given as effects of force. Let us see the first point. Okay, the first point is a force can cause motion in stationary. So a force can cause motion in a stationary object. Any stationary object, any example you can take, like a force can, motion means to, if any object is rest means we will take rests when we get we will take rest first. If we get in Telugu ayasam, if we get an ayasam like that, we will take rest now, like that. That is the meaning of rest. So Rest means not moving, only at one place only, staying at one place only. That is known as rest. Motion means moving. Only moving only is known as motion. For any stationary object, force can change, cause motion also. If here is a box, it is at rest position. It is at rest position. If we apply force to that, it moves to motion and again stops. So it got motion. No? So that is the meaning of the first point. Force can cause motion in a stationary object. So now the second point is if a force can stop the moving objects or slow them down. Okay. Here is an object. It if a force can stop the moving object, it is in motion means it is moving in a speed. To this side the object is moving. If we apply force to the opposite side, the object may stop now. That is the meaning of the second point. A force can stop the moving object, or otherwise it can slow down also. If it apply less than the speed of box, if the force applied less than the speed of the box, it may slow down. If we apply more than the speed of box, it may stop. That is the meaning of this second point. Okay, and here is the third point. A force can make a moving object move faster. If here is a box moving towards east direction, again if force added more, the object may move faster. If this object is moving 60 kilometer speed, okay, this object is moving 60 kilometer, if more speed added, then it can increase speed, like it became 100. So it can increase the speed also. That is the meaning of third point. Let us see the fourth point. See, force can change the direction of the moving object. If an object going to this side, okay, it came here. If we keep force this side, it moves this side. That object moves to this side. So the direction also has been changed now. So force can change the direction of the object, direction of the moving object. So force can change the direction of the moving object. That is the meaning of the fourth point. And the fifth point is force can change the shape of the object. Force can change the shape of the object. If here is one of the which is clay. So here is one of the clay which is in circle shape. If we press the clay with our two hands, two fingers, if we press it and keep force, add force to press it, it becomes like this. So now the shape is like oval shape. oval shape, uh, and here is circle. Then when we added force on the clay, the shape has been changed. So force can change the shape of the object. Force can change the shape of the object. That is the meaning of the fifth point. Okay, we have completed effects of forces. So let us recapitulate the definition of the force. So once again we will recapitulate the definition of force. So here is the definition. Force is an external agent which changes or tends to change the state of rest or uniform motion of a body or changes its direction or shape. Okay, or otherwise if you want this definition you can take this definition, or otherwise a force is a pull or push of an object, that also you can write. So for in force we have two types of forces. Let me show. For so here is the force. In force we have two types of forces. One is contact force and another one is non contact force. Wait a minute. Non contact force. These are the two types of force. One is contact force and the one is non contact force. So let us know about these two forces. First we will know the definition of these two forces. So here we can see the definitions of the two forces. This is the definition of contact force and this is the definition of non-contact force. Okay, this is the definition of contact force. So let us know about the contact force definition. All forces which acts on a body directly or through a connector are called contact force. So if all the forces, every forces acting only on a one body, nothing but one object, only on all the forces acting only on a one body directly, acting directly on one body or otherwise through a connector or otherwise directly, those are known as contact force. Okay, if all the forces directly acts on only one body, directly acts only on a one body is known as contact force, or otherwise it can connect with connect it can connect with a connector also, through a connector also. So this is the definition of contact force. All the forces which acts on a body directly or through a connector are called contact force. And here are some examples of contact force. Examples: spring force. This is the example of contact force. And here is the definition of non-contact force. The force which do not make direct contact with a body but act through a space are called action at a distance or called non-contact force. So the force which do not make direct contact, the force which do not make any contact, direct contact, it does not make any direct contact with any body, but it acts through a space. It maintains space. It maintains some space between them. Okay, that is the meaning of the non-contact force. So non-contact force, we can call it as action at a distance force. Action at a distance force. Wait a minute. We can call it as action at a distance force, or otherwise we can call it as non-contact force also. So here are some of the examples for non-contact force. So the examples are magnetic force, gravitational force, and electrostatic force, and etc. Let us know some more kinds of forces. Okay, see, here are some kinds of forces. And the first one is muscular force. Second one is mechanical force. Third one is gravitational force. So muscular force definition is the force generated by the force produced by the muscles of living beings is called muscular force or biological force. The force which produced by our human beings muscles will be no muscles. Those are muscles. Okay. Which the force which produced by these muscles by a living being is known as muscular force, or otherwise we can call it as biological force also. So the next one is mechanical force. The force generated by a mechanic are called mechanical force. The force which is generated by a mechanic, you know, no, mechanic who repairs the things is known as mechanic. The force which is generated by a mechanic is called mechanical force. No mechanic produces force on its own. In order to produce force, we must supply it with some kind of energy. Okay? No machines produce forces on its own. In order to produce force, we must supply it with some kind of energy. We should use some kind of energy also. Everything will not produced by machines now. We also should work some with our own energy. So the next one is gravitational force. Earth pulls all objects around it towards its center. This pull exerted by the earth on the body is called force of gravity or gravitational force. If a ball thrown into the sky, it again comes down to the earth on the earth. So this is known as gravity. Up to here the ball goes and again it comes down. Due to gravity, this process going on. So earth pulls all the objects around it towards its center. Earth pulls all the object, every object around its towards its center. This pull exerted by the earth. This pull exerted by the earth on the object is called force of gravity or gravitational force. We can call it as force of gravity also. Okay. Formula for calculating gravitational force. For solving some sums, formulas are used now. So formula for calculating gravitational force. Formula for calculating gravitational force. So the formula is F is equals to m into g. F nothing but force is equals to m nothing but mass into g nothing but gravitational force. Here given no. So m nothing but mass of the body. I have said no mass. M is equals to mass. So g nothing but gravitational force. So g nothing but acceleration due to gravity. Last gravity is there now. That is gravitational force. So g nothing but acceleration due to gravity. Okay. Something given about the acceleration due to gravity. Let's learn. So the acceleration produced in the body while it is falling is due to the gravity of the earth. So the acceleration in the freely falling body is called acceleration due to gravity. So the acceleration produced in our body while it is falling due to the gravity of the earth. So while the body is falling due to the gravity, the acceleration is produced in our body. That time the acceleration is produced in our body. Then so the acceleration in the acceleration in the freely falling body is that is known as acceleration due to gravity. That is known as acceleration due to gravity. Okay. It is represented by g. So acceleration due to gravity is represented as g. Letter g. Generally its value is 9.8 meters per second square. Generally its value is 9.8 meters per second square. Okay. Gravitational force is also known as weight also. So here is the definition of weight. Okay. The force by which an object is attracted towards the earth is known as weight. So the force by which an object is attracted towards earth is known as weight. And the next one is electrostatic force. Electrostatic force. So what is an electrostatic force? It is the force between charges. It is the force. It is a force between the charges. So it is a force between charges. It is a force between charges. Next one is magnetic force. Next one is magnetic force. The objects of iron or steel move towards magnet, therefore we can say that they are acting upon by magnetic force. The magnetic force can easily pass through substance like wood or glass. The objects of iron or steel moves towards magnet. The objects like if any object like iron, steel moves towards magnet, no. Therefore, we can say that they are acted upon by magnetic force only. The magnetic force can easily pass through substances like wood or glass. Magnetic force is also can be passed easily through wood also and glass or glass also. So let us go into the next. So here are some other forces, and here is normal force and its definition. Here is given example diagram also for understanding the definition of normal force also. Okay. The arrow mark which is going upwards, is known as normal force only. Why it is normal force we will understand in this definition. When a body is pressed against a rigid surface, the body experiences a force which is perpendicular to the surface in contact. This is called normal force. So, when a body is pressed in a rigid surface, then the body experiences one of the force acting. Experiences a force when it pressed on a rigid surface. It experiences a force which is perpendicular to the surface in contact. This is called normal force. Okay. Its object is pressed against the rigid surface, so it got an perpendicular. It got an experiences of force which is in perpendicular to the surface in contact. Perpendicular only now. So it is normal force. Here is another force given, that is tension force. Okay. It is an external force developed among molecules of a string or rope against applied force. It is always a pulling force. Okay. It is an external force developed among molecules. This force is an external force which is developed among the molecules of a string or a rope. It is developed on a molecules of string or rope against applied force. It is always a pulling force. Okay. It is always a pulling force. Tension force is always a pulling force. Okay. Now let us see units of forces. Units of forces. We need smaller force to lift smaller objects and large force to lift larger objects. Actually, we need smaller force to lift smaller objects and larger force to lift larger objects. So, see. Next point. Here is the next point. The unit commonly used for measuring gravitational force is called kilogram force. The unit which is commonly used for measuring gravitational force is known as kilogram force, which is an unit which is used for measuring gravitational force is known as kilogram force. Kilogram force. Symbol is kgf and gram force symbol is gf. Symbol for kilogram is kgf and symbol for gram force is gf. Okay, so here are some to know some more about kgf and gf. So 1 kgf is nothing but 1 kgf is equals to 1000 gf. 1 kgf nothing but 1000 gf. So 1 kgf nothing but 9.8 Newton. So 1 Newton nothing but 10 power 5 dynes. 10 power 5 dynes. Okay, let us move to the next point. The next point is, in SI system, unit of force is Newton. The SI system of the force is Newton. The SI system of force is Newton. So Newtons can be written as N, capital N. It is the symbol for the Newton. Symbol of Newton is N. And the CGS unit of force is CGS unit of the force is dyne. In CGS system, unit of force is dyne. So force CGS unit is dyne. Okay. And next point is, force is measured by using spring balance. Force can be measured by a spring balance. Okay. Force can measure by using spring balance. Wait a minute. And here is the last point. A force can be larger or smaller. The magnitude tells us how large or how small is a force. A force may be larger or smaller. Anything it may be. The magnitude tells us how larger and how smaller is the force. The magnitude tells us. A force may be larger or smaller. The magnitude tells us how larger and how smaller is the force. Okay. Here are some examples. The examples are 60 newtons and 50 newtons. For example, they have given these numbers 60 newtons and 50 newtons. So in the down of the examples they given the explanation also by taking these numbers. So let's see. 60 and 50 are magnitude of force. 60 newtons and 50 newtons. See once. And the given diagram of the forces. See once. Both are acting towards east side and they kept the forces as F1, F2. They given the forces as F1 and F2. In middle, one of the object is moving to the east direction. So given the direction of force is from left to right as shown in the figure. So they given 60 newtons and 50 newtons as 60 newtons direction to east and 50 newtons given as the arrow mark given as direction to towards east side. Okay, here given east side direction. Okay, see next point. Here is the next point. See, if two forces acting on a body in same direction, the two forces should be added. If any two forces acting at the same direction, those forces should be added. Here for example you take the both forces are acting at same direction, so the both forces should be added. So 60 plus 50 should be added. So example I will say. So resultant force. So F is equals to F1 and F2. They added F1 and F2 because these both are in same direction towards, these both are acting towards the same direction. That's why they taken F is equals to force is equals to F1 plus F2. Okay, and let us move to the next point. If two forces acts on a body in opposite direction, the forces subtract from each other. Resultant force. If any two forces acting at opposite direction like this, those forces should be subtracted like this. F is equals to F1 minus F2 because these both are acting opposite direction. That's why they should subtract each other. Okay, that is the meaning of the last point. Let us in the next video we will so in the next video we will learn, I will give practice paper for you. So we have completed today's Newton's laws of motion, about Newton's laws of motion. So let us recapitulate what we have learnt. We have learnt about force, effects of forces, two kinds of force in two kinds. Those two kinds are contact and non-contact force, and we know about non-contact and non-contact, and we have learnt about kinds of forces. In kinds of forces we have learnt muscular force, mechanical force, gravitational force, and we learnt about formula for calculating gravitational force, and we learnt about acceleration due to gravity, about electrical force, magnetic force, and about weight. We learnt about next normal force, tensional force, and we learnt about units of forces. These we have learnt in today's class. In the next video I will give you practice paper. So thanks for watching this video. If you like this video, please like, share and subscribe to our channel. We'll meet in the next video. Bye.